In this lesson, we are focusing on our transformations with translation and reflection, but focusing more on the coordinate rules, not just the visual, but the coordinates. So like with the translation, I know it's over here on the right, but starting with the translation, which is our slide, if I wanted to know just 2 to the left or 4 up or 1 right, 3 down, how does that rule look coordinate form and vector form? So here, if I'm going 2 to the left, well, think about the X and Y axis. If I'm going left and right, that is referring to the X. So 2 to the left means we're focusing on the X. And if I'm going to the left, that's going towards all of the negative. So this would be X minus 2, and then nothing happening with our Y coordinate, which means in vector form, so we have these symbols here, and that would just be -2, 0. So again, what is happening to the X and Y? So then 4 up. Well, up and down is the Y axis. So that means if we're going up, now we're adding, we're going positive. So nothing with our X coordinate, but this would be Y plus 4. So then in vector form, this would be 0, 4. So then last, 1 right and 3 down. So left and right is your X, and up and down is your Y. So now if we're going to the right, that's positive, X plus 1, and down. So Y minus 3. So then vector form would be 1, -3. Then the reflection rules. So when we are reflecting over the x-axis, we're not going to change the sign of the x, we're going to change the sign of the y. So here we're starting at our original xy and then transforming to x but negative y. So we're changing the sign of the y. So if we're reflecting over the y-axis, that means now we're going to change the sign of the x coordinate. And when you're reflecting over y is equal to x, your diagonal. That is when you switch the coordinates. So xy now becomes yx. So then if you're reflecting over y is equal to negative x, which is the negative slope, if you think about it right, -1, then not only are you switching the coordinates, but you're also negating both as well. So these are the rules that we'll be going back to and using today in this lesson. So like here in number 1, in our examples 1 and 2, we're identifying the transformation, but we're going to not only identify words, but also the coordinate form and the vector form. So I notice here, starting with our original, we're going to the left. How many units? So starting at R, ending at R prime. We are going 1, 2, 3, 4. So 4 to the left, which matches, right? Because here's S. 1, 2, 3, 4 to meet up with S prime. So 4 to the left. So how would this look coordinate form? Well, we moved along our X and subtracting 4. So X minus 4, and we did not go up or down. So leave Y, which means vector form would be -4, 0. So then number 2, here going, starting at Y, let's say, we're going up 2, right 1. So 1 to the right and 2 up. So again, just make sure with X, right? 2 up, 1 to the right. So coordinate form, left and right is your X, and we're going to the right. So X plus 1, and we're going up. So Y plus 2. Therefore, in vector form, this would be 1, 2. So go ahead and pause the video and try the U-try on your own. And here we go. So let's say starting from G and ending here at G prime. We're going 1, 2, 3, 4 up, 1, 2, 3, 4, 5 to the left. So 5 to the left and 4 up. So that means coordinate form, we're subtracting 5, right, from our x coordinate. So x minus 5 and 4 up. So y plus 4, which means in vector form, this would be negative 5, 4. Now in example 3, we are given the triangle. So let's say S here is at 0, negative 2, T is at negative 1, 3, and U is at negative 2, 1. Now we are applying this translation rule here, where we are adding 2 to X, so we're going 2 to the right, and Y minus 1, so we're going 1 down. So that is literally, though, what we are doing with the X and Y coordinate. So we're going 2 to the right, so we're adding 2 and subtracting 1 from our Y coordinate. So 0 plus 2 is 2, and then negative 3. So let's see if it matches. So we're saying now here we're at the point 2, negative 3 for S prime. So here we went 2 to the right, 1 down, which matches. So then adding 2, 1, subtracting 1, 2. So 1, 2, here's your T prime, and U prime, which is at 0, 0 as well, because negative 2 plus 2 is 0, and 1 minus 1 is 0. And here is our U prime. So notice how our image did get moved, translated 2 to the right, 1 down. So go ahead and pause the video and try the U-try on your own, given now in vector form. And here we go. So now notice this is just the X value, like this is X minus 1Y, which means we're only going 1 to the left for our translation. So A is at 2, 4, B is at 2, 1, C is at 3, 1, and D is at 3, 4. So if you're just going 1 to the left, that means we're just subtracting 1, like what it says here, from the X coordinate, leaving the Y alone. So now we're at 1, 4, 1, 1, 2, 1, and 2, 4. So when plotting, 1, 4 is A prime. 1, 1 is B prime. Notice how here they just got moved 1 to the left. So then 2, 1 is C prime, and 2, 4 is D prime. And here is that new rectangle shifted, translated 1 unit to the left. So now moving on to the reflection. So again, here we're used to this, right? But also practicing writing the rule. So like, for example, I see that we are reflecting, and I can look at my coordinates, let's say for S. So S is at 1, 2, 3, so negative 3, 1, 2, 3, 4, 5. So S is at negative 3, 5. Then notice S prime is now at positive 3, 5. So notice what happened. We changed the sign of the X coordinate. Notice here that shows a reflection over the Y axis. So we have a reflection over the Y axis, and the rule is changing the sign of the X and keeping that Y coordinate. Like here with number 5, a lot of people at times would say, well, this could be like a rotation. Then check the coordinates, right? So like here, I've got, let's say Y. Y is at, oops, sorry about that. Y is at 0, negative 2. Then Y prime is now at negative 2, 0. So what happened? We just switched the coordinates. So this is saying that we are reflecting over Y is equal to X because we switched the coordinates. Now, another way to check that we reflected over Y is equal to X. So this is like with a slope of 1, right? So starting at 0 with a slope of 1. So it's like drawing this line here. This is Y is equal to X. If this is a reflection, you would have straight lines here. So like here, straight line. Notice here with our slope. we have that straight line. So one more time, keeping that slope the same, right? Notice how everything matches. And same thing here, S to S prime, R to R prime, T to T prime. Notice how we're creating that straight line. These are just a slope of 0 versus here we have a slope of -1. So notice how those lines can also tell too that this is a reflection. So go ahead and pause the video and try the U-try on your own. And here we go. So now just to check, let's say I'll choose H. H is at -2, 1. H prime is at -2, -1. So notice we change the sign of the y coordinate, which matches because this is a reflection over the x-axis. So reflecting over the x-axis, which means our rule is x but -y, changing the sign of the y. And again, if you wanted to see our line, notice how here everything matches, straight line. And so same thing here with example 6. We're going to identify those coordinates. So like right now, A is at 2, 1, B is at 5, 1, C is at 5, 6, and D is at 2, 6. Now, we are reflecting over y is equal to -x. So what is the rule? Well, we're not only switching the coordinates, but we're also negating both. So that means A prime is now going to be not just 1, 2, right? We don't just switch them, but also negate both of them. So -1, -2. So B, we're not just switching them, but also negating both. Same thing, don't just switch the coordinates for C, negate both the x and y. That means D prime is at -6, -2. So when we plot, just to check, -1, -2, -1, -5, -6, -5, -6, -2. So notice how here is our reflection, and then let me go ahead and label our reflection over y is equal to -x. So again, now we have a slope that's -1 and reflecting over. So how can we tell? Well, again, you can draw the straight lines to see that here everything is going to match up and show you have your reflection. So go ahead and pause the video now and try the U-try on your own. And here we go. So identifying our coordinates for JKLM, our parallelogram, here we're at -6, 2, -4, 6, -3, 3, and -5, -1. Now we are reflecting over the y-axis, so the rule is we change the sign of the x-coordinate. So here, J prime, right? So if we're changing the sign of the x, now that means we're only focusing on the x. So now it's +6, 2. So K is +4, 6. Here, +3, 3, and here +5, -1. So again, changing the sign of the x coordinate. So then when you graph, you can see, so 6, 2 is J prime, K prime is at 4, 6, L prime is at 3, 3, and M prime is at 5, -1. So notice here, we do have that reflection over the y-axis, creating those straight lines here and showing that reflection. So now just taking away the picture and focusing on the coordinates. So like here, for example, if we just want to identify, and this is a mixture of both of our rules here, translation and reflection, going from A to A prime, will I notice We changed the sign of the x coordinate, nothing to do with the y. When we changed the sign of the x coordinate, that was a reflection, but over the y-axis. So like looking at number 8. Well, notice they are both changed here, which means this is a sign of a reflection. So to go from -5 to -2, we add 3. So then to go from -1 to -6, well, what do? Subtract 5. So here, this is x plus 3, y minus 5, which means we translated, but what directions did we translate? We translated 3 right and 5 down. So like number 9, we have a double. So we're going to need to identify what happened first and then what happened second. So here, our first, well, I notice we not only switched the coordinates, right? Notice how they got switched, but we also changed the sign. So this is -y, -x. We switched the x and y and negated both, which shows a reflection, but over y is equal to -x. Then from here, notice, yeah, okay, we changed the sign, but we went from -7 to -5. So that is a sign of a translation. So to go from 1 to -1, we subtract 2. So then to go from -7 to -5, what do? We add 2. So this rule is x minus 2, y plus 2. So what did we ultimately do? We translated 2 left and 2 up, because this is our left and right, and here is our up and down. So then number 10, we're starting with a at -12, 9. Then we're going to translate -6, -2. So here's our x and here's our y. So we're going left 6, 2 down. So here that means our a prime, we're subtracting 6 and subtracting 2. So now we're at -18 and 7. Then the second transformation, we are then reflecting over y is equal to x. So what is our rule? We switch the x and y coordinate. So this becomes y x. So here, if we're at -18, 7, then a double prime is at 7, -18. So go ahead and pause the video and do the U-tries on your own. And here we go. So in the first U-try, you should have noticed you just switched the coordinates, the x and y. So this is a reflection over y is equal to x. Then the next, we just switched the sign of the y coordinate. The -3 changed to +3. So this is a reflection, but over the x-axis, because you changed the sign of the y. Now here we had a double, so first and second. First, you should have noticed, is a translation. You had x minus 5, subtract 5 from x, and add 1 to y. -6 plus 1 is -5. So here you are translating 5 left and 1 up. Then from here, we kept the y, but changed the sign of the x coordinate. So this is a reflection over y-axis. Then the next. So we started at A, 22, -14. The first transformation states that we are reflecting over the x-axis, which changes the sign of the y. So now we're at 22, +14. Then the second transformation, you translate 8 left, 1 up. So you are just subtracting 8 and adding 1. So now we're at 14, 15. Then last here, we're starting at A, negative 13, 11. We are now going to first translate 5 units down, 2 units right. Now, you should have noticed, down means this is your Y. Right means this is your X. So this is X plus 2 because we're going to the right, Y minus 5 because we're going down. So you had to add 2 to your X and subtract 5 from the Y, making A prime negative 11, 6. So then here, the second transformation, you are reflecting over y is equal to negative x, which means not only are we switching the coordinates, so now we have 6 and negative 11, but also change the sign of both. So this is negative 6, positive 11.